Brian, like has been announced, is not here to share this presentation with you. He's currently in Mexico at one of their assembly plant facility, launching the same technology that I'm going to share with you. And actually, he just sent me a text confirming that the conversion been successful. So that's another motivation to share this presentation with you all. So I don't think I got the clicker. Is this one here, right, guys?
Yeah. Yes.
Okay. Great. So before jumping into the core of this presentation, I would like just to give an overview of what PPG offering and solutions to sustainability. Sustainability has been a topic of recurrent topic in the industry for so many years. And PPG, like all the different suppliers, coating suppliers in the industry, have been embracing this concept, this philosophy. So PPG, like right now, we are focusing on the pretreatment. This topic is centered about pretreatment. We do have offering and solution for our customer to meet their internal sustainability goals along PPG sustainability goals. So similar to what was presented prior. So in pretreatment, we do have two core chemistries, zinc phosphate and thin film. PPG also offered these two core chemistries. So for VersaBond, under this brand, we identify different type of chemistries, offering different solutions, different deliverables, and a different temperature in order to achieve your sustainability goals. Like Chemkleen is one of our offerings, and that's our low temp zinc phosphate that marries perfectly with the technology I'm going to share now. And also our ZircoBond, which is our thin film pretreatment, which allows processing aluminum at a higher content. And that was one of the problems when it comes to zinc phosphate. You have a limitation on how much sludge you generate with zinc phosphate. So that's why a ZircoBond and the thin film in general is going to unleash you to process higher content of aluminum. So when it comes to developing new technologies, PPG has always conscious about outside factors, and not just within the United States, but globally. We look globally, like in terms of regulations, region by regions, and that is going to impact the way we develop and deliver and make products for you guys. And this technology, the technology that I'm going to share with you, talk about with you, is going to fall under this approach. So low temp cleaner. So this is the codes, the technology CKSP3, which is a builder, and CK188A, which is our surfactant package. Basically, that's a 2K product. So this is just like a footprint of a standard zinc phosphate line and a ZircoBond line. Like was presented before, you can convert a ZircoBond stage to zinc phosphate stage into a ZircoBond thin film. So these are like, you can look into like green fields probably. But how can I go back? So cleaners are the core of the pretreatment process, because you need to prepare the surface for the conversion coating. So you need to make sure that the surface is ready and free of impurities, lubricants, anything that can impact the conversion coating process. So when we looked into developing this CKSP3 technology, we tried to maintain and deliver the same attributes to our existing cleaner technology that we have commercially available, but at a lower temperature. So our standard cleaner, traditional cleaner, so the operating range is between 50 to 70 C. With CKSP3, which is our low temp cleaner, we drop the temperature even lower. So right now we're talking between 38C to 52C. That's the range, operating range for this technology. So when it comes to the sustainability purposes, so we try to definitely eliminate all these surfactants that are being of concern. So we try to formulate removing all the EPA and PE surfactants. So then we look in terms of supply chain. We try to make sure that this technology can be launched anywhere in the globe without having any problem in terms of raw material availability. And also to make sure that the technology is the same, utilize the same product and same material across the globe. And also to marry with additional low temperature conversion stages. Like I mentioned before, the zircon thin film typically operates at a lower temperature. And this is perfect because you're gonna have like a low temp cleaner and then associated with a conversion coil that operates at a lower temperature. So far, so good. We discussed, introduced the technology, but when it comes to actually make it and formulating, so we run into some challenges. So when it comes to challenges that we had to overcome in order to provide this, develop this technology was like maintaining foaming performance. Foaming is a problem. When you drop the temperature, foaming is like, it's a problem. So we had to be creative in order to reduce the stability of the foam that's generated. So also we had to maintain the etch on aluminum. So etch is typically depending on temperature as well. So when you drop the temperature, the kinetics, everything is gonna be reduced. So we had to maintain the etch on the aluminum substrate. And also we had to improve the efficiency of our non-ionic surfactants. That's part of the formula of our surfactant package. And for that reason, we looked into the HLD model in order to maximize the selection of the surfactant that are gonna be part of this technology. So now, from now on, I'm gonna just show you the development steps that we took to generate this technology, provide the benefits that we defined at the very beginning of the conceptualization of this product. So cloud point is one property of the surfactant that we took into consideration. That's the temperature at which the surfactants become most active in your solution. We had to look at the HLB, which is hydrophobic balance or rate. So basically that tells you take into account the behavior of the surfactant at that particular solution, that particular temperature. And also some defoamer, because we had to control the foaming for the high surfactants that have a higher HLB value. So, so I know that I've been talking about this HLB, so about what it is exactly. So HLB is a properties that identify the property of the surfactants. Surfactants are, you have a portion that is hydrophobic and a portion that is hydrophilic. Typically, it's like identified like a hydrophilic head and a hydrophobic tail. So this ratio takes into account the behavior of the surfactant in solution and how they will perform. So that's a key value when you start formulating cleaners. So the rule of thumb is like higher HLB value typically is more hydrophobic, hydrophilic, and compared to when the HLB value is lower, which is more hydrophobic. And keep in mind that those values for the surfactants are tabulated. So we know exactly what this value is for each surfactant. So how we're gonna use this HLB value to formulate, and how do we use this value to select our surfactant, to build our surfactant package. So the goal is to clean the surface of your substrate and remove the oil. So we need to identify the HLD of the oil, because similar HLD are able to remove or interact with oil that have similar HLD. Since we are dealing in an industry where typically we use different type of lubricants in the body shop, so we don't target one HLD, we target an average value of HLD. So how do we identify this average? So we cannot screen the entire oils available in the industry. We select a pool, a larger pool of this oil. And there's a theory, the larger the pool within a set of oils, the average is going to be closer to the full average of the pool oils. So basically, first we identified the HLD for each oils. We look at the average, and that's the target that's the average that we are targeting, looking for our surfactant package. So then, so for HLB, we identified the surfactants, but also we tried to fine tuning those surfactant package selection. So for HLB, as I mentioned earlier, that's a property of the oil. So then we looked at HLD, which is a different methodology to screen for surfactant and oil, both of them. This is different. That takes into consideration, it's a property of the full system. So that's a formula that identifies the HLD, just for your knowledge. So since it's a property of the full system, we are looking at the surfactant characteristic, we are looking at the oil factor, then there is a temperature dependence, and also the salinity of the builder. And typically closer to 0, the better. Actually, something else that we have been optimizing for this technology, because as I mentioned, like when you lower the temperature, you also impact all the performances. So that was screened through different DOEs, and then statistically we looked at the best formulation that provide the best edge that we target at the time. Cleanability is another thing that we are going to screen, because that's what a cleaner is supposed to do, clean and remove everything in the oil in this case. So typically you look at the water break to assess the efficacy of our cleaner. For our development, our preferred method was the OptiBright. OptiBright is similar to a carbon mapping. So basically we took a panel, we clean it, then we mix the oil that we're trying to target, or the mixture of oils, with a dye. Then, and then we apply this oil doped with dye on the surface of the panels. Then we clean the panel, but we apply like the process in order to partially clean it. Because I mean, if you clean it, you remove the oil, you remove the dye, and then everything looks clean, and you cannot differentiate between prototypes. So what we did, we partially clean, and then we screen the panel using it's called ImageJ, the software that we utilize. And similar to a carbon mapping, we looked at pixels of those dyes. Gives you pretty much the kind of coverage similar of the oil on remnants of the oil on the panels. And then we looked comparing between prototype or between our control, which is our current cleaner. So what we are looking here is just like the readout is a value that has a relationship to the pixel of the unclean panels. So lower the value, it's better. So that's how we were able to screen through different prototypes and also compare it to our control. And as you can see here, that's a comparison between our CKSP1R, which is our most popular cleaner, compared to our CKSP3, which is the technology that we just discussed about it. And you can see that has a better power to clean compared to CKSP1R. And also foaming is something that we had to control. And because of that, we had to do some reformulation to look at different deformers in order to reduce the foaming at a lower temperature. So this is the technology journey with GM. So we shared this technology, we discussed this technology with GM, in particular with Brian Nguyen. They were interested. We reviewed it. We did an approval, completed in 2022. And then we launched in a GM SLP, which is a plant in Mexico, it's a zinc phosphate plant in Mexico, in 2024. You may ask, why these 2-year gaps? So in these 2 years, we launched at the same plant our low temp zinc phosphate. So we prefer to launch a zinc phosphate first and then follow it back to back with our cleaner. So right now the plant has like all the stages are operating at a lower temperature. And that was a successful launch. So in the box below, you have the lesson learned from the launch, all the saving that GM was able to capture with this technology. So here you have the annualized saving for energy consumption. Here we are able to, after converting to CKSP3, the plant was able to save 3,584 megawatts per year. They also were able to capture some water saving. Cleaning and maintenance was reduced compared to the previous technology. That required less boil outs. And also this sludge generation is lower compared to the previous technology. And this concludes my presentation. Any questions? Sure.
With the increase in the use of dry film lubricants in the automotive industry over the past, I don't know, decade or so, and some of these have melting points at 120 or 130 degrees Fahrenheit, how will this cleaner deal with that?
So that's a good question. So like you mentioned before, like dry lubricants. So the way you clean them or remove from the surface, it's driven by heat and impingement. So obviously I can see here, like this is a lower temperature. So that will make the removal a little bit difficult.
And since I have the microphone, I have another question. You talked about etch and with probably the builders, alkaline builders and chelating agent. I mean,
Yes.
Will it make it more difficult to treat in some of the waste treatment plants if the chelator is more aggressive or stronger?
So we have a etch target, which is similar to the one for the previous technologies. So the amount of material that you remove, it's not excessive. So they should still be able to process whatever it's being removed. And for the purpose, we always, before conversion, we always work with our wastewater treatment, do our jar test, making sure that they are able to process any byproduct, any metal that's being etched out, clean out, or anything. So yeah.
Thank you.
But typically we try to be very conscious about everything that can impact before and after. Thank you. Oh, you're welcome.
Any questions here in the room? Okay, I'll move to the questions posted in the app. Is CKSP3 able to apply a controlled etch on aluminum and galvanized mixed metal production lines?
Yes.
Something related to the dry flame lubricant. Does PPG have an HLB value for dry flame lubricants as well as oil-based lubricants?
they can be extrapolated. I mean, and some of these can be also, they are tabulated. You can find, talking with the suppliers, they should have it.
Okay.
It's more than that, is the, sorry, it's a mixture. That's an unknown, and that's where we typically experimentally extrapolate the HLB values. But for a single component, typically they're tabulated. Yeah.
How are process parameters adjusted to maintain the H loss?
So that experimentally, because it's H is also impacted by the quality of your water. So on paper, it's not easy to determine, but I mean, experimentally, like if, like, let's say, different regions, different cities have different water quality. So that can impact the chelators, and the chelator, as a consequence, has an impact on your H. So, yeah.
I have one last question here. Is GM-SLP a zinc phos line? Is GM-SLP a zinc phosphate line?
Yes. SOP is a zinc phosphate line, and the one that was just launched was a thin film line. So, yeah.
So that was the last question. We have some time left. If there are any other questions that the speaker can answer. Okay.
Correct. Yes. Yes.
So thank you very much.
No, thank you, guys.
Thank you.
Thank you. Thank you.